All right, I believe we're live. So last week I was putting together a story about El Nino for KSBW Channel 8 along the Central Coast. And I was doing my research for this story that I was putting together, and I was finding all sorts of different information online, and honestly it was a little bit confusing until I came across ggweather.com. This is one of the best weather sites out there. If you don't know this one, it's put together by Null. He's probably one of the top meteorologists in California. And it answered all the questions that I had. It was perfect for the story I was putting together. But then I messaged him on X and I said, hey, thanks for organizing all that material. That was just what I was looking for to answer some of my questions. Questions like, does El Nino actually lead to more rainfall in California? Does it always lead to more rainfall? Why is it different than La Niña? Does El Nino arrive, or is it something that just sort of happens? I had all sorts of questions, and he answered them all. And while we were chatting, he forwarded me this link, which is El Nino and La Niña Misconceptions. And there's 6 of them here. And I was reading this for the second time today, and I realized just how useful this is in terms of information, because during the early part of my research process, I realized there's a lot of information out there that's not exactly true. And this link right here clears it up pretty perfectly. And I think we should be able to go through these 6 common misconceptions in, I don't know, maybe 10, 15 minutes. So if you want to learn more about El Nino and La Niña, you can go through this little article with me. And if you want to follow along, I put the link for this site in the description of this video. So once again, El Nino is in the news, and there is already lots of hand-waving and exciting predictions about how it will impact this winter's weather across the United States and elsewhere. And clouding the picture even more is the hyperbole wrapped in many myths, misconceptions, and misinformation about what El Nino and La Niña are and their impacts. And I'm going to be honest, on a couple of these, there were actually things that I believed, and I may have even said on air at some point, that this clears it up. So this is a very good source of information right here. Wish I'd known about this maybe 2 years ago. So first myth that we're going to bust right here. El Nino or La Niña will soon arrive in California. So no, neither ever comes to North America. Rather, they are phenomena that periodically occurs in the warm equatorial, keyword there, equatorial waters of the Pacific Ocean. Normally, the trade winds along the equator push the warmest waters into the western portions of the Pacific. So basically, trade winds push warm surface water over, you could think of it over to Asia. But on an irregular basis of typically 2 to 5 years, that right there could be its own misconception of how often El Nino occurs. Some sites I was seeing were saying 5 to 7 years. This is saying 2 to 5 years. Personally, I'd trust Null more than the other sources that I was looking at. So, but on an irregular basis of typically 2 to 5 years, the trades slacken or sometimes even reverse direction, and warmer than normal water accumulates along the equator in the central and eastern Pacific. This warming is called El Nino, referring to the Christ child because its effects are greatest in the winter and often disrupt fishing along the South American coast around Christmas time. So, if you're more of a visual learner, basically what happens in a neutral year, you can see you have your trade winds, and it's going to be pushing warm surface water to the western Pacific. During El Nino, those trade winds aren't as strong, or they even reverse, and some of that warm water comes rushing back to the eastern Pacific, especially off of South America. And key word there is equatorial, and that's what that red blob right there represents. And if you look at some of the sea surface maps right now, you can actually see this red blob developing right off of South America. And then in La Niña, you can basically think of that as the reverse of El Nino, or a strengthening of the normal pattern. So normally you have warm water on the west, you have cold upwelling on the east, and in La Niña, those trade winds are maybe even just stronger, so then it strengthens that process. And then I also just like this part about the naming of El Nino. It goes back, I think, hundreds of years. It was South American fishermen, I believe mostly in Peru. Every, I guess, 2 to 5 years, they would notice that the water off the coast would be exceptionally warm. There'd also be less upwelling, which I believe means there's less nutrients, which means there's less fish, and then that can have huge impacts on the fish and then the bird populations. So the fishermen noticed that, oh, we get all this warm water every 2 to 5 years, and it impacts our fishing, and they noticed it would peak around Christmas. So that's where the name El Niño comes from. That translates not to El Niño, it translates to the boy, and it's a reference to the Christ child because, again, it would peak right around Christmas time. I just think that's an interesting little kind of side note on where we get the name. And then La Niña, that is the girl, and it's basically because it's the opposite of El Niño. When the trades strengthen and the waters off the eastern Pacific are cooler than normal, it is called La Niña. So, yeah, basically what that normal process is when it's strengthened, that's La Niña. So, basic summary there. El Niño or La Niña doesn't arrive in California. It's more warm water along the equatorial Pacific during El Niño, and then cooler than normal water along the equatorial Pacific during La Niña. So, that's myth number 1. Let's go on to myth number 2. All El Niños and La Niñas and their impacts are the same. Now, on face value, most people probably wouldn't assume this because anything in nature, nothing's going to be exactly the same. So that'd be a pretty hard one to say true. But you do often hear people say, oh, El Niños are rainy and La Niñas are dry. But this is going to explain why that's not exactly true. So, are they all the same? No. While El Niño and La Niña only occur in the tropics, their impacts are felt in many parts of the world. So the phenomena is in the tropics, but then it can have impacts, let's say, on places like California, or it actually can impact places all over the world, as that statement just says. This happens because the location of the huge mass of warm water for El Niño and cold water for La Niña may cause the location of the jet stream or storm track to shift. As a consequence, some regions can become warmer or colder, or wetter or drier than historic normals. However, not all ENSO, that's the combined word, so El Niño Southern Oscillation, that's the collective term for both El Niños and La Niñas, events have the same strength or location, and consequently their impacts can vary significantly. So, basic summary there is, El Niño, La Niña happens mostly in the tropics of the Pacific, but then it can have impacts all over the world, and those impacts are going to vary significantly. So in general, the larger the area and the greater the warming of the Eastern Pacific's equatorial waters, the greater the impact on other regions. And remember, that can happen through kind of displacing the jet stream or moving the storm tracks. When you have the jet stream going directly into California, that's going to bring storms into California. If it shifts a little bit farther north, like it has been the last week or two, then it brings more storms up to Washington. And El Niño can just kind of change where that jet stream is and maybe even how strong it's going to be. So, the most common metric for classifying ENSO events is the Oceanic Niño Index, ONI, which identifies how much above or below normal the sea surface temperatures are for a specific region, El Niño 3.4 of the Eastern Tropical Pacific. It should be noted that a number of researchers are continuing to refine the identification of ENSO events related to where within the 3.4 region and adjacent regions it occurs. So, my basic understanding of what we just read is they're measuring where El Niño occurs, so equatorial Pacific. They're measuring how much the sea surface temperatures are above normal during El Niño or below normal, which would make a La Niña. And then that's kind of the metric that they use, this Oceanic Niño Index. So right here, there's a lot of numbers and dates in this next section. I'm not going to read all the different years, but there are some very interesting kind of historical examples right here, which perfectly disprove this myth of all El Niños and La Niñas and their impacts are the same. And it even kind of puts to bed that myth that, oh, El Niños are rainy and La Niñas are dry. So since 1950, there have been 26 years when the equatorial Pacific warmed enough to be classified as an El Niño. There have been a total of 11 seasons, beginning in the years, those ones, classified as weak El Niños. So 7 weak El Niños out of the 26. 7 years as moderate, 5 years as strong, and 3 years as very strong El Niños. So what this index is measuring is how strong the El Niños are. And not everyone is going to be the same. You have, let's see, you got 11 weak ones, you got 7 moderate, 5 strong, 3 very strong. Conversely, there have been 25 years when the equatorial Pacific sea surface temperatures cooled more than normal to be classified as a La Niña. A total of 12 seasons beginning in those years are classified as weak, 6 years as moderate, and 7 years as strong La Niñas. So just right there, you can see that the intensity of the El Niño or La Niña is going to change. And this is a pretty cool graphic right here. On the bottom, you have your dates. And then you can see when these lines go up, that's going to be going up into El Niño territory. That's the red, strong El Niño. Anything with those numbers written in red, that's where your strong El Niños are. So it looks like 2015, 2016, that was a strong El Niño. It was actually up in the very strong category, measuring by those bars. 97, 98, that goes into very strong. What about a strong La Niña? Looks like in 2010, 2011. That index for La Niña, so below normal sea surface temperatures, was way down there. So you can see how this shifts back and forth throughout time, and it's irregular. So it is extremely important to note, I'll let you keep looking at that while I read this. It is extremely important to note that ENSO is not the only large-scale climatological phenomena that impacts the world's weather. And what we're about to read is some of the explanation for why not El Niños have the same impacts. It's because there's lots of different things going on in the atmosphere at the same time, and all of those things interact in different ways. It's almost kind of like in wildfire, where it'd be tempting to say, oh, if you have 24-mile-per-hour winds, then your wildfire is going to burn this many acres per day. But it also depends what the temperatures are doing, and the relative humidity is doing, and what your fuel moistures are like, and your topography. So there's lots of different factors that all combine, and that's the same thing with what you could call climatic patterns over large time and space scales. So ENSO's impact in any given year is dependent on not only its strength, but also on the location and the extent of the event along the equator in the eastern Pacific Ocean. It's also a function of ENSO's interaction with the whole alphabet soup of other indices and oscillations, such as the PDO, which is the Pacific Decadal Oscillation, NAO, which is the North Atlantic Oscillation, AO, which is the Arctic Oscillation, and MJO, which is the Madden-Julian Oscillation. I think alphabet soup is kind of the perfect way to summarize all the different oscillations that we have. And looks like if you go to the link in the description, you can click on those and probably learn a lot more about those, but don't think I have time for that in this video today. Maybe that's the source for some future videos. We could learn about those. But El Niño is kind of the main thing people are talking about today. So let's go over these maps right here, because this summarizes some of the impacts that you have. So we've already kind of debunked that each El Niño is going to be the same. There's all sorts of different intensities that you have. Now let's look at this, where it says, even within the same ENSO category, there can be significant differences. For example, the two most recent weak El Niños, 2006 to 7, and 2018-2019 were quite dissimilar. So not only can an El Niño be weak or moderate or strong or very strong, but even within the weak events, you can have very different impacts. So if you look at 2006-2007 El Niño, all of California is in the red. which means it was a weak El Nino and we had below average precipitation. And down in Southern California, they're in the dark red, so it looks like they had well below average precipitation. And I'm mostly just going to be covering California throughout this video, but here you can see the impacts that El Nino has not only on California, but throughout the rest of the country as well. And you can imagine there's other impacts throughout the rest of the world. So weak El Nino, 06-07, California, extremely dry. Then you have a weak El Nino, 2018-2019, and California looks extremely wet. So let's see if we can find it on here. 2018-2019, yeah, you can see that those lines go up to the weak El Nino. So that's what we're looking at there, but then that ended up being a very wet year. Then if we look at very strong El Ninos, so you might say, oh, maybe the weak years, there's more variety because, yeah, it's not that strong of an event, so it's not going to have that big of a role. So now let's look at a very strong El Nino. So 1997-98 versus 2015-2016, comparing these two very strong El Nino events. In 97-98, almost all of California is in what looks to be the darkest blue color you could have. So that's an extremely rainy year. I imagine anyone who has lived in California for a while probably remembers that year. And then if you look at 2015-2016, we did have above average precipitation in Northern California, slightly above average for the Central Coast, but then Southern California actually looks like it was a dry year. So just right there, if you'd been around for 97-98, you'd have the maybe tendency to associate El Nino with a lot of rainfall because you remember this year. But let's say you're down in Southern California, you're going into the 2015 season, and you hear, oh, it's going to be a very strong El Nino, and you think, oh, that means we're going to have a ton of rainfall, there's going to be a ton of flooding, and then it actually ends up being drier than normal. So the last example we'll look at is La Niña, comparing weak La Niña, 17-18, with the weak La Niña of 22-23. So weak La Niña, 17-18, looks like all of California extremely dry. And then I think everybody remembers the 22-23 water year. All of California extremely wet, especially the Central Coast. It's almost like that blue color needs to go up into purple for how much rainfall we picked up this last water year. So just right there. That's also a very good example where you might be tempted to say, oh, El Nino leads to a lot of rainfall. But I mean, the rainiest year that I can remember in my lifetime was last year, and that was a weak La Niña. Technically, I was alive in that one, but I don't remember that one. So extensive 1950 to 2022 ENSO U.S. winter precipitation climatologies categorized by strength can be found at that link or that link. I think those were the links I originally found that answered all the questions that I needed to have answered for the story that I put together for the news. And detailed ENSO climatologies for California at that one and that one. So one additional takeaway is the need to look beyond more than just the ONI. If you forget what that acronym stands for, it is Oceanic Niño Index. A larger view is presented in differences between 15-16 El Nino and previous strong and very strong events. And not even all ENSO indices are the same as seen in which El Nino index is best. So that just complicates things even more. We're looking at this when comparing, oh, this very strong year to this very strong year. But then you could even say that, well, what if you just use a different index? Then that's going to change your data and your categorizations. So then that's going to change things as well. So that throws another wrench into the idea that all El Ninos are the same, or that we can pull out simple, generalized explanations and predictions based on what's happened in the past. So that was number 2. Just going back up to quick summarize, El Nino or La Nina will soon arrive in California. That's a no. It's in the equatorial Pacific. All El Ninos and La Ninas are the same. That's a no. They vary in intensity, so they could be weak, moderate, strong, and they vary in their impacts. 2 very strong years could either be, one could be very wet, one could be very dry. And then El Nino could end up being dry, and La Niña could end up being wet. So now let's move on to number 3. El Nino and La Niña are storms. So once again, not true. El Nino is not some sort of large superstorm that sits over an area for the winter. You will never see it on a satellite, a radar image, or with your binoculars at the beach. It simply causes a pattern change that sometimes leads to variations from normal precipitation and temperature patterns. So the one way you maybe could see it is if you look up sea surface temperature anomaly map, and that's where you can see some of the warm water rushing back to the eastern Pacific during an El Nino year. You can see that right now, but it's not like when you look at water vapor imagery and you could see an atmospheric river moving in. It's nothing like that. So, and they also do not spawn storms. El Nino and La Niña do not directly create any storms over California or anywhere else. It shifts the usual jet stream patterns so that some areas can be more susceptible to storm formation. So basically what that's saying is if your ocean changes temperature, then the air above that's going to change temperature, and then that's going to shift your jet stream, which you could think of as the boundary between your cooler air and your warmer air. Where those come together, you have a lot stronger winds because you have large temperature and pressure gradient. And then if El Nino is impacting your temperatures, then obviously that would impact that gradient, where the jet stream is, maybe how strong it is. So El Nino kind of indirectly impacts where your storms are going to be, or perhaps how strong they would be. But it'd be wrong to say El Nino creates storms. Consequently, they should not be used as an adjective in phrases such as El Nino flooding, El Nino storm, or La Niña drought. Think of it as the Pacific Ocean and the overlying atmosphere being on a performance-enhancing drug. I love this analogy he uses right here. And just like we don't know why an athlete will have a great performance one day and be mediocre the next, we don't know whether a particular weather event during El Nino or La Niña year would have occurred anyway. So I like that analogy because performance-enhancing drug for, let's say, Barry Bonds. I was an old Giants fan, grew up watching Barry Bonds hit all those home runs. With performance-enhancing drugs, he was much more likely to hit a lot of home runs, but he may still have some games where the entire game he does nothing but strike out. So that could be like El Nino overall might enhance rainfall in California, but you could have some years where it's just completely dry. That's like the strikeouts. So, number 4, El Nino equates to a rainy winter in California and elsewhere. So we've already kind of covered this, but now we're actually going to break down some of the numbers. And that can be a little daunting at first, but this chart is actually just the perfect answer to the rainfall question. We've already kind of seen it in map form. Now this is going to show us in number form. So, does El Nino mean rainy winter in California and elsewhere? The answer is no. The real answer is not always and not everywhere. Historical records for the past 7+ decades for the San Francisco Bay Area show that during the 26 El Nino events, the rainfall has been almost evenly split, with 8 of 26 years having well below normal precipitation, so less than 80% of your normal rain. That means, just putting easy numbers on that, if you normally see 10 inches, you would have less than 8 inches. So 8 of the 26 El Ninos were like that, so dry years. 7 of 26 were near normal, so 80% to 120% of normal. And the final 11 of the years being substantially above normal, so greater than 120%. That's like if you normally got 10 inches, you had more than 12 inches. So this chart right here, we'll just break it down by axes. So table 1, all El Nino events, average percent of normal seasonal precipitation. So just like the numbers we were just talking about, 10 inches versus 12 inches would be 120% in this chart. Then we have ENSO type on the, what you'd call that, the y-axis. You have all El Ninos. So this, I can't highlight this. You have all El Niños on the top, weak El Niños, moderate El Niños, strong El Niños, very strong El Niños. So let's just look at a couple of these here. San Francisco Bay, all El Niño. Actually, let's go across the board. All El Niños look to be within that near normal range. So 80% to 120% of normal, except for those last three columns right there, where you're above 120%. Then let's look at the comparisons going from all El Nino to weak, moderate, strong, very strong for, let's go San Francisco Bay. Weak El Ninos actually end up being a little drier on average. And then for very strong, you end up having well above average precipitation on average. So again, that's not every year. That means if you were to look at the number of events in those 26 years that were very strong and average those up, San Francisco Bay would be 160%. So I'll go through just one more because I know numbers can get a little hard to listen to. Let's go Central Coast. That's my home now. So we'll look at that one. All El Ninos. Yeah, it looks like there's an overall trend where you end up picking up a little more rain than normal. During weak El Ninos, it's actually dry. And then as you go up to very strong El Ninos, that's pretty significant. 168% of your normal rain on average. Again, not every very strong event means you're going to be very rainy for the Central Coast, but overall, you can kind of draw that correlation there. So over the same span, the Sacramento hydrologic region had 8 very wet rainfall seasons and 9 very dry during El Nino season. So what those numbers are basically saying is it's not that great of a predictor of rainfall. While you may be able to create these generalizations and these averages, if you look at it by the numbers, when it comes to predicting what's going to happen this year, you're maybe as likely to be dry as you are to be wet. So the Southern California coast hydrologic region showed more of a wet bias during El Nino with well above normal rain in 13 of 26 seasons, near normal for 6, and well below for 7. So they were well above normal rain in 13, well below for 7. So that's certainly not a bet I would put too much money on, whether you're going to be wet or dry if an El Nino is happening. The bottom line is that California can get wet during El Nino, but it is near or below normal almost as often. As a matter of fact, the California drought in the 76-77 winter was during a weak El Nino. It is important to keep in mind that El Nino is not the only thing happening in the atmosphere, and that there are other global patterns, and that other global patterns can either enhance or detract from its overall impact. So there we're talking about the alphabet soup again of the Pacific Decadal Oscillation, Madden, Julian, all those ones that we talked about earlier. So, what was that one? Number 4 was El Nino equates to rain. You can maybe create some overall generalizations, but you wouldn't want to put your life on that bet because you're just as likely to be wet as dry. So, El Nino means disastrous flooding for California. This, I think, was the most interesting one that I read. I've already read this a couple times. And this one, you'll see towards the end here, really caught me by surprise. So no, only occasionally does El Nino mean disastrous flooding for California. It is just as likely that California will have significant flooding in a non-El Nino year. Of the 10 costliest flood years in California since 1950, only 4 happened during a season where there was El Nino. That's a pretty interesting fact right there. So your 10 costliest flood years in California since 1950, only 4 were El Nino years. 2 others occurred during seasons with La Niña, where you would be tempted to say, oh, La Niña means it's going to be dry. 2 of the 10 of the costliest flood years in California history were during La Niña. And the final 4 were when the temperature of the tropical Pacific was near normal. That's pretty interesting right there. That's still not the part that kind of blows my mind, though. The major weather pattern that causes flooding in California is when a strong surge of subtropical moisture dumps copious amounts of rain over a portion of California for 5 to 7 days. Probably already know what I'm about to say here, or what name you've heard for this. These are so-called atmospheric rivers, also called Pineapple Connection or Pineapple Express. I actually was watching a lecture today, or a webinar on atmospheric rivers, and I figured out where these words come from. Atmospheric river comes from the fact that it literally is like a river in the atmosphere. It's concentrated water vapor, and it can have twice as much water as the Amazon. And you might be wondering what's the difference between the Pineapple Express and an atmospheric river. The difference is Pineapple Express is typically when you're talking about the ones that move into the West or move into California, or it's not exactly right to say move in. You'd say transport water vapor into California from Hawaii. But atmospheric rivers happen everywhere around the globe. In fact, at most times there's 3 to 4 atmospheric rivers happening. So atmospheric river is the general term, whereas Pineapple Express might be a little more specific or localized or regional for California or the West because it's coming from Hawaii. And just the last thing I'll say about atmospheric rivers there, I know this is an El Nino video, but after watching the webinar today, I learned lots of cool things about atmospheric rivers. It sounds kind of sensational to say atmospheric river, but just like El Nino, it doesn't just mean you're going to have disastrous flooding if there is an atmospheric river. In fact, if we didn't have atmospheric rivers, California's water supply would be in pretty bad shape. If you have atmospheric rivers, our water supply is usually good. Sometimes you have strong ones that leads to flooding. But if you don't have atmospheric rivers, then California goes into drought, and that certainly has its consequences as well. So basic thing I'm trying to say there is atmospheric rivers aren't some simple, it's bad because it leads to flooding. It's also very good because, California needs water, and most of our water does come from atmospheric rivers. So continuing here, these are so-called atmospheric rivers, and they are actually slightly more prevalent during years when there is no El Nino. So that was the line that surprised me the most. I would have thought, El Nino happens, you're going to have warm water, so there's going to be more evaporation, there's going to be more water vapor, that means your atmospheric rivers are going to be more likely, and then maybe they're going to be stronger as well, lead to more flooding. But that basically just disproves what you might intuitively think. So this is saying atmospheric rivers are slightly more prevalent during years when there is no El Nino. So hopefully it answers it in the next paragraph here. But maybe the reason for that is because the water is so warm, maybe that shifts the storm track a little bit north. So then you end up, it kind of redirects the jet stream, so you have less atmospheric rivers. Could be a lot of things going on there. That's just kind of my guess. So continuing, the last very strong El Nino in the winter of 97-98 is a good case study of a wet El Nino year, but one with no widespread major flooding. So now this is, again, looking at El Nino means disastrous flooding for California. What we've already talked about is, most of your flooding comes from atmospheric rivers, and those are actually less likely during El Nino. And then this is also saying, let's look at a case study. 97-98, this is where there was a lot of rainfall, but there wasn't major flooding. Despite nearly double the normal rainfall over most of California, there were nearly twice the number of days of rain with no huge concentrated deluges, and statewide damage totals were about 500 million. Compare this with the flooding that took place around New Year of 97, a period with no El Nino, when a week's worth of warm atmospheric river rainfall resulted in 1.8 billion in damage statewide. So interesting. I'm a little confused by this one because it says the last very strong El Nino in the winter of 97-98. But then it says New Year of 97, a period with no El Nino. I'm wondering if maybe I'm reading that wrong, or maybe if one of those dates is incorrect, or... Oh no, maybe the New Year of 97 would be your 96 to 97 year. Yeah, that makes sense. Okay, we're all good there. Just had to figure out what was going on. Basically what that's saying though is, in 97, 98, you had a very strong El Nino, but it ended up being the best way to pick up rain, where it was minimal rain over a long period of time, instead of like this New Year of 97, a period of no El Nino, where you had a lot of rainfall over a short period of time, and you had 1.8 billion in damage statewide. So that's pretty interesting as well. Now let's go on to the last one. Just recapping that one, El Nino means disastrous flooding for California. No, disprove that one, and I'd say that was the most surprising myth that was busted for me. So El Nino, number 6 myth, and the last one, El Nino means warmer, La Nina cooler than normal sea surface temperatures along the California coast. So this is one that I may have said incorrectly on air, because our water was really warm in the Central Coast over, I think it was maybe towards the end of summer. I even had one day where I surfed in board shorts. And I think I said something on the air where I said like, oh, we're developing El Nino and all the surfers can feel it. It's pretty warm out there. Wrong. Very wrong. El Nino means warmer, La Nina cooler than normal sea surface temperatures along the California coast. That's a no. So, and it's also not responsible for the variety of warm water species of marine life reported recently. The same with La Nina and cold water species reported off the California coast. An analysis of sea surface temperatures along the California coast shows that overall the sea surface temperature anomalies do not correspond with those in the eastern tropical Pacific. So remember, El Nino is warm water in the eastern tropical Pacific. What this is saying is it's not warm water off the California coast. So in Northern California, during El Nino years, in a 2-degree square, so that little square right there on the map, between Point Reyes and Big Sur and about 100 miles offshore, the sea surface temperature anomalies were only warmer than normal in 5 of the 13 years. So looking at El Nino, you're looking at 13 El Ninos, only 5 of the years in that box did we have warmer than normal sea surface temperatures. And during La Nina years, they were warmer than normal 9 of 15 years. So it's actually the exact opposite of what you would expect. We were warmer than normal more often during La Nina off the California coast than during El Nino. So not only was I wrong, but not only was what I said about, oh, warm water off the California coast, that's El Nino, not only was that not true, it was anti-true. You're actually more likely in La Nina, but still 9 of 15, that's not that great of a correlation. So it doesn't really seem like there's any correlation between El Nino and your water temperatures off California. In Southern California during El Nino years in a 2-degree square, so now we're looking down there, between Santa Barbara and San Diego and about 100 miles offshore, the sea surface temperature anomalies were only warmer than normal 6 of the 13 years. And during La Nina years, they were warmer 8 of 15 times. So once again, Southern California, during El Nino, you're only warmer than normal 6 of the 13 times. And then during La Nina, 8 of the 15 times. So you're actually more likely to be have warm sea surface temperatures during La Nina than El Nino, which is the exact opposite of what you expect for California. Again, remember, El Nino is warm water in the eastern tropical Pacific. And then La Nina is extra cold water in the eastern tropical Pacific. So that's very interesting. I'm glad I now know that so that I no longer say that incorrectly. So what's the bottom line here? As we transition into what will likely be a moderate El Nino event of unknown intensity, there is already a storm of speculation and the gnashing of teeth, while historic teleconnections between what is going in the eastern tropical Pacific and the eventual winter weather across North America should not be ignored. It is important to keep in mind that those relationships are not as linear as once thought, and that many other factors, including climate change, need to be part of the equation. The bottom line is that there are no guarantees, implicit or implied, in enso-climatologies, and they are definitely not intended as forecasts. So, Jan Null pretty much summed it up perfectly right there at the end. Let's just go over the 6 one more time. El Nino or La Niña will soon arrive in California. No. It is warm. El Nino is warmer than normal water in the eastern equatorial Pacific, not California. All El Nino and La Niñas and their impacts are the same. Not true. You can have different intensities where some are weak, some are moderate, strong, very strong, and then your rainfall is going to be different as well. In 2 weak years, it could be dry or it can be wet. In very strong El Niños, it can be very wet or it can be dry. And then La Niña, it can be dry or it can be wet. So then you might wonder, well, why do we associate El Nino with rainfall? And that's because if you look at the averages, there does seem to be a correlation, especially with very strong El Niños, that you end up picking up more rainfall than normal. But even with that, you're just as likely to be dry as wet. It's just in some of those wet years, it ends up being very wet. So, but then, yeah, not a great predictor of rainfall. So, number 3 was El Nino and La Niña are storms. It's not, it's just warmer than normal. El Nino is warmer than normal water in the equatorial Pacific, and that can maybe impact your storm track or where the jet stream is. But it would be incorrect to say it is a storm, or even that it creates storms. Number 4, El Nino equates to a rainy winter in California and elsewhere. No. You have all these numbers, and overall it does look like very strong El Niños on average are about 150, I'm just going to round that, 150% of California's normal rainfall. But when you break down the numbers, we'll just look at those. 8 of the 26 were well above normal precipitation, 7 of the 26 were near normal, and of the final 11, and the final 11 years were substantially above normal. So, yeah, just as likely to be wet as dry. And then 5, El Nino means disastrous flooding for California. I think this was the most surprising one. It does not. Most of our flooding comes from atmospheric rivers, and those are actually less likely during El Nino. And then you can also have very strong El Niños where it's just nice, gentle rainfall spread out over a long period of time, or a year with no El Nino that has a huge atmospheric river and leads to billions in damage. So El Nino means warmer, La Niña cooler than normal sea surface temperatures along the California coast. That's our last myth. And that one was busted as well. El Nino, think equator when you're thinking about your sea surface temperature anomalies, not the California coast. In fact, you might even have the opposite being true, that you're actually more likely to be warm during La Niña off of California, which is very interesting. Did not know that. So I certainly learned a lot while reading Jan Null's El Nino and La Niña Misconceptions. Again, the link for this is in the description. On Jan's website, GG Weather, there's tons of links that you can go to that has all kinds of great information. So I definitely suggest you go check it out. And I just realized I planned on this being about 10 to 15 minutes, but I believe we're pretty far over time at this point, so I'm just going to wrap it up. Hopefully you learned something throughout the course of this video. I'm going to go through another one of Jan Null's El Nino pages tomorrow, where we're going to break down a lot of the different maps and kind of really drive home the point that El Nino doesn't technically just mean it's going to be rainy. So you can stay tuned for that. And yeah, hopefully we'll just learn a lot more about California weather together over the next few months and next few years. So hopefully you enjoyed this video, and thanks for watching.